Hello students, welcome back to Physics with Safdar. Now you are watching IGCSE Physics Past Paper Solution series. In this series we are solving questions from paper 2, 4 and 6. If you are facing any problem in your IGCSE Physics, so you are at the right place. Here you can find the solutions of your all problems of IGCSE Physics. I suggest you follow the playlist of the channel. In that you can find all the things you need for your IGCSE Physics. Today we are going to solve paper 2 solution on topic electrical quantities and electric circuits part 2. So let's start the solutions of the day. This is question number 8. Question number 1 to 7 we have done in part A. Question number 8. The circuit diagram shows a fixed resistor and a thermistor T used in a potential divider circuit. Look at this circuit. This is power supply, thermistor resistor and fixed resistor. You need to remember the symbols of thermistor resistor and a fixed resistor. Then VR and VT are the potential differences across R and T respectively. What happens to VR and VT as the temperature of thermistor decreases? Look at this column. This is voltage drop across fixed resistor. Second, voltage drop across thermistor. So you can label the voltage drop across thermistor is VT and voltage drop across fixed resistor is VR. This circuit is a series circuit. How to identify it? First mark the polarities. This is plus and minus. We always flow the conventional current from positive to negative terminal of the supply like this. The current enters thermistor, then fixed resistor, then return to the power supply. Since current is undivided or current is flowing in a single path, that's why components are called in series circuit. In series circuit, voltage drop across a component is proportional to its resistance. This is very important point to solve this question. In series circuit, voltage drop across a component, it depends upon resistance. Look at the last line. Temperature of thermistor decreases. Thermistor is a very special type of resistor. Its resistance depends upon its temperature like this. At high temperature, its resistance decreases. And at low temperature, its resistance increases. So look at this last line one more time. Temperature of thermistor decreases. That means its resistance increases. When the resistance increases, look at this expression, then voltage drop across thermistor increases. That means the voltage drop across fixed resistor decreases. So look at the option what we have. Option A, voltage across fixed resistor decreases. That's true. Voltage across thermistor increases. Also true. Both options are correct. A is the right answer here. Question number 9. There is a current of 3 amperes in a conductor. The current is changed to 6.0 ampere in the opposite direction. Which effect does this have on the magnetic field around the conductor? And you have 4 options. Look at the first portion. We have this conductor and it's carrying current 3.0 amp. Okay. Let's suppose this is positive and negative. You know well we take direction of current from high potential to low or positive to negative as a convention. Current has the magnetic effect, so this current produces magnetic field around this conductor. In the second case, what we do, conductor you have but this time this conductor carries current 6 ampere in the opposite direction. That means you can take positive at this side, negative here. The current flow in this case 6.0 M to right to the left. Remember one thing, the size of the magnetic field due to the current, it depends upon the size of current. Of course, when you increase the size of current, the size of magnetic field increases. And look at the direction as well. The magnetic field direction also depends upon the direction of current. So in the second case, you reverse the direction as well. So what would happen in this case? The size increases and the direction of magnetic field reverts with respect to the first case. Now look at the options. Option A, it decreases. That's not true. And act in the opposite direction. Cross this one. It decreases. Not possible. Cross. It increases. True statement. And it acts in the opposite direction. Correct statement. Check the last one. It increases. This part is okay. Same direction. That's not possible. Cross this one. Option C here is the right answer. Question number 10. Which electrical quantity is defined in terms of the energy supplied in driving charge around a complete circuit, and you have 4 options. Remember this formula, energy supplied per unit charge. This energy supplied per unit charge is called electromotive force. So look at the option. Current, cross this one. Electromotive force, that's true. It's not potential difference and power. B is the right answer here. Question number 11. A student sets up a circuit containing a battery of 2 cells and 3 lamps as shown in this diagram. What is the circuit diagram for this arrangement? And you have 4 options. This is cell number 1, cell number 2, and this is you can see 1, 2, 3 lamps. You need to know what is the correct circuit diagram for this combination. It's very simple. First start with the direction of current flow. This is the positive of the supply. We always take direction of current from positive to the negative. Current start from here. Enter this lamp 1, then lamp 2. Look at this point. When the current reach at this point, then current divide. Few current through this lamp and second in this path. So this is the point, let's suppose A. At this point the current divide. When the current divide, then components are called parallel. So last 2 lamps are in parallel combination. Then current return to the negative terminal of the supply and complete its round. Look at this 1 and 2. Option A, first mark the polarities plus and minus. If you have symbol like this, it shows a single cell with positive and negative terminal. If you have lines like this, it shows combination of cell, that is called battery. Okay, so look at the option A, plus and minus. Current start to flow from positive. This is the lamp 1, current is entering. After reaching this point, the current divides into 2 parts. That is showing parallel combination of component. Then current recombine from here and from this point and return to the supply. So circuit A is the best representation of this combination. Option A is the right answer here. Question number 12. The current in a kettle is 10 amperes and the kettle is protected by a 13 ampere fuse. The owner of the kettle replaces the 13 ampere fuse with a 3 ampere fuse. What happens when the kettle is switched on? Remember one thing, fuse is the protection of your appliance. It is very simple. Look at the rating. The current in a kettle is 10 amp and it is protected by fuse 13 ampere. It is very simple rule. If you want to protect an appliance, what we do, how to select the rating of fuse? More than and near to the rating of the supply. For example, here you have 10 amperes for electric kettle and 13 ampere is greater than near to this number. But when you replace with this 3 amp, that is not greater than and near to the 10. It is less than 10 ampere. So what would be the effect of this fuse? This fuse will melt quickly. When this fuse melts, the circuit breaks and your appliance cannot work. So that's why we need to check what is the right answer here. When you replace 13 ampere fuse with 3 amps, the fuse melt, that is okay. Kettle might be damaged, not possible, because when the fuse melt, current cannot reach to the appliance. The fuse melt, this part is correct, and the kettle is undamaged, it's okay. B is the right answer, but check the others. The fuse does not melt, not possible, cross this one. The same with the D, the fuse does not melt, not possible. Option B is the right answer here. Question number 13. In which circuit does the lamp light? And you have 4 circuit diagrams. In the circuit diagram, you can see one symbol like this. This is called diode. Second, you see this symbol. This is used for lamp. And third, you can see like this. This is a power supply or a battery. Look at this component that is called diode. It has a special characteristics. It allows the current flow only one direction. For example, this part looks like a triangle. If the current enters from this side, then it allows the current to the right. If the current enter opposite, then it does not work or provide a very high resistance. That's the rule you need to remember. It allows current only in one direction, as I told you. Now look at the circuit diagram one by one. First, mark the polarity. This is positive and negative. Current start with the positive terminal, then reach at this point. Current divides like this and here, but look at this. This vertical line stops the current, so current cannot through this track, the current through this path, then here. But look at this, again you have this opposite, so current cannot flow further. The lamp cannot lit in this case. Cross this one. Look at the second, plus, minus. Current start from here. After reaching this point, divides like this. But look at this point. These lines are vertical. Current cannot cross this because they provide high resistance. It will not light up. Cross this one. Third one, plus and minus. Current start with the positive terminal. Look at this. Now you can see this triangle part. current can enter easily, then out. Look at the second, the same you have, so current can flow easily and reach to the lamp, and the lamp start glowing. So that is correct. C is the right answer, but check the last one also. Take positive and negative. Direction of current from positive. The first portion is okay. Current can through this part, but after reaching here, look at this. This is opposite direction. It stops the current. So that's why D cannot be our answer. Finally, C is the right answer here. Question number 14. The resistance of a wire depends upon its length L and its cross-sectional area A. The resistance is, and you have 4 options. Look at this diagram. The resistance of a wire depends upon its area and length like this. This is the length of the conductor and this is the cross-sectional area. Or in easy word, if you are confused with the cross-sectional word, you can take as a thickness of the conductor. If you have a thick conductor, it has a large cross-sectional area. If you have a thin conductor, it has a small cross-sectional area. The resistance of the conductor depends upon the length and cross-sectional area as it's proportional to the length. That means a long conductor provide high resistance. N, resistance of conductor is inversely proportional with the cross-sectional area. That means a thick wire gives low resistance and thin wire gives high resistance. So look at the options. Option A first. Resistance is directly proportional to the length. This part is true. And directly proportional to the area, not. Cross this one. Directly proportional to the length, true statement. Inversely proportional area, also true. B is the right answer here. Check the others. Inversely proportional to the length, cross this one. Inversely proportional to the length, cross this one. B is the right answer here. Question number 15. In the circuit shown, the ammeter reads 2.0 ampere and the voltmeter reads 12 volt. How much energy is transferred by the resistor in 10 seconds? Look at this circuit diagram. This is the power supply of voltage 12 volt. Ammeter for measurement of current and voltmeter for measurement of potential difference or voltage. You need to calculate how much energy is transferred by the resistor in 10 seconds. Energy transferred, you know well, you can calculate by using this formula, power multiplied by time. And for the power, we have 3 expressions. Power you can calculate V into I, voltage and current. You can calculate power by using V square over R, voltage over resistance. And you can calculate power by using I square times R. So look at the options. You have I and you have V. And time is 10 seconds. So here we are going to use the formula of power, V times I. Then you have time. Now put the numbers. V is 12, I is 2.0 and time is 10. Multiply all the numbers, then we get 240. Its energy, so measure in joules. Look at the option. A 2.4, cross this one. B 14.4, not correct. C 240, right answer. And D 1440 joules, not correct. C is the right answer here. Question number 16. The diagram shows part of an electric circuit. The current in 4.0 ohm resistor is 3.0 amperes. What is the current in the ammeter? Look at this diagram. Ammeter is used for measurement of current. This is resistance 4 ohm carrying current 3 amps. Second resistance 2 ohms. We don't know the current through this component. And we need to know how much current is showing by this ammeter. Look at this first portion. 4.0 ohm resistance carry 3.0 amps current. And 2.0 ohms, how much current? We don't know. Look at the number. 4 ohm carry 3 amps. And you know where resistance and current are inverse in relation. High resistance, low current, and low resistance, high current. Here you have 2 ohm, that is lower than 4 ohms. 4 ohms carry 3.0 amps and 2 double of this number, because look at the number, it's half of the 4, so it carry twice the current of 4 ohm resistor, so it carries 6 ampere. You can write like this. Now look at this, these two currents divided before entering the circuit, so that's why the current recorded in ammeter is equals to 6 plus 3 amp, so that is 9 amp actually. So 9 amperes current ammeter then reach this point and divide into two parts like 3 and 6. So look at the options. A 4.5, cross this one. B 6.0, not correct. 9.0, right option. D 12, cross this one. C is the right answer here. Thank you very much for watching this video. I suggest you follow the playlist of the channel. In that you can find all the lessons you need in your IGCSE physics. So keep watching Physics with Safdar for better results in exam. See you in the next lesson.